Hello, this is Scott Denstead, and here's the latest 2-minute aviation weather video tip sponsored by aviationweatherworkshops.com. A forecast for non-convective low-level wind shear is perhaps one of the most misunderstood aviation weather forecasts. Understandably so, a pilot hears the term wind shear and immediately jumps to the conclusion that severe turbulence is likely. It's a common misconception, but non-convective low-level wind shear is not a forecast for turbulence. In fact, in most cases, the air is glassy smooth. The Terminal Aerodrome Forecast, or TAF, is one place where pilots may see a forecast for non-convective low-level wind shear, such as the one shown here for Baltimore. Additionally, the Aviation Weather Center in Kansas City also issues a forecast for non-convective low-level wind shear. This forecast, however, is unfortunately labeled as AirMet Tango. Since most pilots equate AirMet Tango to a forecast for turbulence, they also believe a forecast for non-convective low-level wind shear is also a forecast for turbulence. The relatively new graphical AirMets, also issued by the same meteorologist at the Aviation Weather Center, takes this a little further and separates the advisory for moderate turbulence with the advisory for low-level wind shear. In this example, the low-level turbulence and low-level wind shear products are both selected. The non-convective low-level wind shear forecast simply tells the pilot that the wind will increase by more than 20 knots within the lowest 2,000 feet of the atmosphere. If widespread moderate turbulence were also expected, the Aviation Weather Center would have included a separate area similar to the area of moderate turbulence below 18,000 feet shown to the west. As it turned out, there were 2 pilot reports in this region that reported negative turbulence at 2,200 and 2,500 feet MSL, or within 1,500 feet of the surface. Non-convective low-level wind shear is also easily captured on the SKU-T log-P diagram for Kansas City International Airport, which is right in the middle of the advisory. There's a classic temperature inversion with winds at the surface of 14 knots increasing to 48 knots, roughly 2,000 feet above the surface. The temperature inversion creates very stable air in the lower atmosphere with very little mixing despite the higher winds aloft.